Hey guys, welcome to your 12.5 notes on samples and surveys. By the end of the day, you will be able to classify data and to analyze samples and surveys. What this means is you'll be able to do something like this. You have a situation where a manager of a Thai food restaurant wants to know how often people in her city eat Thai food. So she surveys 200 of her customers and displays the results in the histogram over here. She concludes that the people in the city eat Thai food at least 10 times per year. Is her conclusion valid? Well, let's look here. Look at our histogram. If they eat at least 10 times per year, there's these guys and these guys and these guys. That's a pretty valid conclusion, except she surveyed 200 of her customers. You guys, her customers are people who, of course, regularly eat Thai food. So, of course, those people eat Thai food a lot. They literally come to her Thai restaurant. So it does not accurately reflect the whole city because, yeah, her customers like Thai food, but other people in the city might not. So this is one very small example of why it's important that when you're collecting data, you need to be sure of two things. First, that your methods are fair. Like, she only surveyed people who already like Thai food, who already get Thai food a lot. And you also need to make sure that you accurately represent the results. Okay? So when we're talking about data, we're going to group them into two kinds of groups. First is by like qualitative versus quantitative, and then by the number of variables. So first we have quantitative data, and when you see quantitative data, look at this, like it talks about things that are quantities. Right, so quantitative data has units. This means that it can be measured and numerically compared. That is, it has numbers that you can compare, numerically meaning number. Examples of quantitative data are things like your age. You could be 14 years old. Your weight, you could be 120 pounds, or the time it takes to do something like 17 minutes, right? You can say I'm older or younger. I can like easily measure someone's weight or time. Quantitative data, that's quantitative data. Qualitative data, on the other hand, more measures qualities. These are kind of subjective. They're not numerical. This is more like a category of things. So qualitative data cannot be measured or numerically compared. Right. Examples of qualitative data are things like hair color. There's no clear definition between like what's blonde and what's not. For example, some people would consider me blonde, but I don't think I am. There's also taste. You can't quantitatively measure taste. I just say like, oh, it's sweet, or I like it. Another fun example is your zip code. And while your zip code, for example, the zip code is school, is 90631. And that's the zip code of La Habra. It is numbers, but it's not measuring anything. For example, the zip code of Cyprus is 1 away, but it's nowhere near La Habra. Cyprus is not 1 less than La Habra for any reason. It's not like La Habra has 1 more person in it or something. It's just how the numbers work, right? You can't compare them with like a number statement. So similarly, pause the video and say, is your eye color, costs, and football jersey numbers, are those quantitative or qualitative? First, your eye color is qualitative. You can't measure it with numbers. it's not numerical. Secondly, costs of streaming subscriptions. Cost is quantitative, and you can measure it with numbers. So that's fun. And then football jersey numbers. Although they are numbers, that's qualitative. Because even though the data are numerical, even though you're working with numbers, they're not measurements. I'm even going to take the time to write that down. You're not measuring like a player's height. You're not measuring their 40-yard time. Some numbers indicate different positions. So like a kicker often is just one digit, and linemen are what, in the 50s or 60s? Don't quote me on that. I don't exactly know. But you're not measuring someone's like speed or height or ability or something. So they're indicative of a position, but they're not quantifying anything. Okay. We have another type of comparison, another type of data in addition to qualitative and quantitative. We have univariate, una, like one, like Uno. Oh, yay. Okay, it has one variable. And then bivariate, like a bicycle or bifocals, that's two. So a bivariate data has two variables. You see variate, meaning variable. So univariate data is when you're just measuring one thing. That could be like your age is 14 years old. It could be like your weight. However, if we're looking at a comparison, we're saying, yeah, it's your age and your weight together. Or if you're saying like the animal type and the their height. I could only think of weight for some reason. Okay. It's important to look at how many variables you're measuring because that will tell you what kind of graph you want to use. So first, if I'm measuring, for example 2, look at each of these guys and determine, is this univariate or is it bivariate? Here, lengths and weights of fish, we are measuring two things, so this is bivariate. For B, the cost of streaming services from different providers, we're just measuring one thing, we're just measuring the cost, that is univariate. And then finally, the atomic weight of elements in the periodic table. Although there are over 100 different elements, we are only measuring one thing. We're measuring their weight. That is univariate. Okay. Now, our key idea of the day is all about gathering information and recording information and presenting that information. So when you want to find data from large groups, it can sometimes be a struggle to measure the whole population. So instead, we just do a small part of it. So when we're collecting information about large groups, the whole group, which is what we call the population, that's the whole thing. Sometimes it's a real struggle to get everyone to participate in your survey, or you don't want to take the time to interview like 1,000 people. So instead, you just measure a small part of that. We call this small part a sample. And then you make conclusions based on what the sample does. So if, I wanted to get a measure of the whole school population of everyone in class, it would take a long time, and some people probably wouldn't respond. So instead, I could just interview some people. I'll call that a sample. And that would help me reason and make generalizations based on what the sample says. Now, it's important to keep in mind what kind of sample we have. There are 3 ways to take a survey. There are 3 ways to find out what your sample is. The first way is my favorite way. We call it random. And when you have a random survey, all you're doing is just randomly picking people at random. Like randomly. Like you could put everyone's names in a hat. Or you could draw your ID numbers randomly from a number generator or something. You could flip a coin, and if it's heads, you get pulled, and if it's tails, you don't get pulled. So that's random. Another way to do it is systematic. according to some sort of system. And this would be like, oh, we're going to pick every 5 people or so. We're going to pick every 7 people. So, and then finally you have stratified. Stratified comes from stratus, which is like a layer. And that's when you separate a population into smaller groups and then randomly choose from there. So if I wanted to get a glimpse of what class culture will like at school, then I would randomly survey like 5 seniors, 5 juniors, 5 sophomores, 5 freshmen, to make sure that I'm getting some of each level of our population. So let's say that a grocery store owner wants to know how much customers are spending on average, and he surveys every customer that uses a discount coupon. That's his thing. He can't take the time to interview everybody, so he's just going to pull people that use a discount coupon. So people who use his discount coupon, that's his sample, and the population is all of his customers. So what sampling method is he using, and is this a good sample? This is stratified. He's grouping people. However, this is not a good group. Why isn't this a good assumption to make? Well, if he only picks people that use a discount coupon, they're probably only buying cheap things, or they want to save money. They're only going for bargains. So you don't want to pick that kind of sample. A better sample would be like every 5th person, or like people with blue eyes, because that really doesn't matter. They're not going to spend more. Yes. Okay. And finally, the most important thing to keep track of when you're analyzing data, analyzing a survey, is bias. And I'm going to make it red because bias is a bad thing to have. A bias is any assumption that will affect your data. Sometimes biases are true and sometimes they're not. So there are 2 ways that we need to look for biases. First, we need to look for bias in a question. Basically, are there any descriptions in your question that are veering people towards one way or the other? And then in a sample, which is what we looked at with the grocery store thing, you need to make sure that your sample represents the population. So let's look at our question first. You have a reporter, and she wants to find out how many voters support the construction of a new highway. She randomly selected voters and then asked them, do you support the economic growth that the new highway will bring? Or are you opposed to the project? This question is biased because clearly you know that she supports it. She's got the economic growth. All right, that's cool. That's a good thing to have. Or are you opposed to the project? No. So she's telling the people that she's interviewing that the highway will bring growth. She's describing you. She's describing the highway as a positive thing. She wants you to support it. So this is biased. Okay? A better way to ask this question would be something like, do you support or are you opposed to the project? Done. Or she could offer insight into both sides. Like, some people support the economic growth that the new highway will bring, yet others are opposed to the project because it is a waste of taxpayer money. Right? So she's offering opinions on both sides. I would say the least biased way is to just, do you support or are you opposed to the project? So again, look for sample when you're determining bias in a question. Look for descriptions that might make one side favorable or make one side unfavorable. And then finally, if you are looking for bias in your sample, you need to make sure that your sample represents the population. For example, we have Lauren wants to determine what % of teens ages 4 through 18 support the arts. So she surveys her drawing class, asking every 3rd student, okay, just every 3rd, whatever random order they happen to walk into class. Good job. We've got a random sample, whether they have been to an art museum in the past 5 years. How is this causing bias? She's already randomly picking them, but what about her sample does not represent the population? She's only pulling from people in her drawing class. So if you're already in a drawing class, you probably like art. So people in drawing classes are artists. I mean, one would argue we're all artists. But they probably like art, so they've probably been to a museum, especially if they took like a class field trip. Now, this is very, very important because the problem with many surveys are misleading because the sample is misrepresentative. That's like asking the esports team how much time they spend playing video games and assuming that is for the whole class. That's like talking to the distance runners and saying, hey, how far do you typically run in a day, and expecting that to be true for the whole track team. It's like going to Fox News and asking someone's opinion, like, how many genders are there? Fox News tends to be very conservative. However, if you went to BuzzFeed, you would get a very different answer because BuzzFeed's audience tends to be a lot more liberal. So they would say, oh no, there are however many, depending on who you ask, right? So it's very important, especially when taking a survey, to keep in mind the political opinions, the ideological placement of your audience, especially of your news source. Keep track of how does my sample represent the population, or is there some sort of bias there? Is there an underlying assumption that not everyone might have? Okay, so choosing samples, pick people randomly, make sure they represent the whole population. And your key idea is right here. Make sure your methods are fair when you pick people, and make sure that you represent the data well. I hope you have a fantastic time on your homework.